Hello and welcome to this course Applied Windows Azure. As the name suggests, this course is about utilizing various Azure building blocks to develop practical applications. When I talk to folks who are just getting started with Windows Azure, they are oftentimes overwhelmed by the wide array of building blocks. So in this course, my goal is to show you 10 distinct practical uses or applications built using these various building blocks. Hopefully, you'll be able to walk away with a use case that applies to your specific domain. And note that the focus of this course is breadth learning as opposed to a deep dive into any given building block. I do assume that you have a basic understanding of Windows Azure concepts such as Azure websites, web roles, worker roles, etc. If you have not had a chance to review some of these basic concepts, I encourage you to go visit windowsazure.com and review these key concepts. And oh yes, my Twitter handle is on the screen. I hope you will reach out when you're watching this course. The value of a course of this type is greatly enhanced by a two-way conversation. Thank you for watching. Let us get started. Let's very quickly take a look at the course outline. As I said earlier, we will be looking at 10 different Windows Azure scenarios. Each scenario will be a module in this course. For each scenario, we will be looking at a functional overview of the relevant building blocks, followed by a detailed look at the core concepts, followed by a review of the key mechanisms that make up that building block. We will then have a review of the design considerations, design trade-offs, if you will. Each building block comes with a set of features. When would you be using that feature? When does it make sense to not use this feature? We'll have that discussion. And then to bring all of these concepts together, I have a completed example for each scenario. And we will walk through important parts of the code for that example, walk through the functional capability of that example. And then before we begin, let me just remind you what I said in the previous slide. The focus again, of course, is breadth learning. I want to leave you with the ability to operate across various Azure building blocks in a coherent, productive way. So when you approach a problem and you're trying to use cloud or you're trying to leverage Windows Azure, you have these various scenarios in the back of your mind and you're able to draw a parallel from these scenarios and then apply it to your given domain. So welcome to this module on Azure websites. In fact, you'll find this title intriguing. Ready-made execution units with Azure websites, and I'll explain that to you. Why am I calling them ready-made execution units? But let's start with a definition of Azure website. So Azure websites are great for hosting web content, and in fact, as is shown here in the bullet, they are great for hosting different web application models, whether it is ASP.NET, PHP, Node.js, or even classic ASP. Now, I have to be honest with you here. When Azure websites first came out, I thought to myself, yeah, it looks like a great tool for building my daughter's soccer team site. And for everything else, I will continue to use the web role. And boy, was I wrong. Over the last year, I've used Azure websites from everything to hosting REST or SOAP endpoints, building SharePoint apps, and of course, building web properties. And through this journey, I've come to see Azure websites as ready-made execution units. So what do I mean by a ready-made execution unit, you ask? I'm calling them ready-made execution units because you don't have to worry about the underlying hardware or software. You don't have to worry about patching. You don't have to worry about clustering to get fault tolerance. Best of all, you get a speedy deployment in seconds. You can also scale Azure website based on the load, or you can scale it based on a time schedule. And you can also monitor the Azure website. So if something goes wrong, you can be notified. So if you look at these capabilities in its entirety, you can think of Azure websites as a completely managed execution environment for hosting any code that you may want to run in response to an HTTP-based trigger. Okay, so another way to look at the Azure websites would be as a way to stamp out these execution units. So you need multiple of these. You come to Azure websites, you fire off an API, you get yourself an Azure website, you host code there, which then responds to any kind of HTTP requests. Okay, so of course, Azure websites are great for hosting web content, but if you look at the characteristics that we talked about in bullet number 2, you can think of them as execution units, and the nice property is that you can stamp them out as needed. So what are the scenarios? What are the common scenarios where you'll be using Azure websites? The first one is, of course, global web presence. So we are talking about large corporate properties like General Motors or American Airlines. Then the next scenario is the digital marketing campaigns. So marketing agencies these days are looking more and more like ISVs. So every campaign that they want to run, they like to provision a new website. An Azure site, given its characteristics, is a very handy way to provision these large number of campaign-based sites. And then, of course, if you're building a business or SaaS applications, today what we are finding is complex middle-tier capabilities that existed earlier are now increasingly moving into the web tier. So today's modern applications are looking more like a web-only tier or web plus data tier, and Azure websites fit nicely into that model. Let us look at how Azure websites are implemented. And one approach would have been to get a large number of virtual machines, install IIS on it, and then every time a new request for Azure website came in, they could have provisioned a virtual directory. But as you will see later, that approach would have been unwieldy. So let's look at how Azure websites are implemented at a high level. So you come in through the load balancer, and as the request comes in, it is routed to one of the ARR or application request routing modules, which is an IIS module. And what application request routing does, you can think of it as a reverse proxy. What it does is it goes and checks against a runtime database to see if you have the quota or the permission to create an Azure website. Once it has determined that you do indeed have the permission to create an Azure website, it is going to go provision a web worker role to host your site. And the web worker role then makes another call into the runtime database. And this runtime database call is very interesting. If you have worked with ASP.NET applications, you have worked with IIS, you know that all of the configuration settings are located in one of the files. And instead of storing all of the configuration data into a file, they have moved all of the configuration information into this runtime database. So we also talked about how it contains the quota information, but the web worker role also goes and checks all of the configuration information here. Once the configuration information is available, it is then going to go to the Azure storage. And there's a concept of Azure Drive. So what is interesting to note here is that the content that you're trying to deliver to your clients is not stored on the disk locally on the virtual machine, which is what a web or worker role is. Instead, that content is stored into a highly available blob storage, which is mounted as a disk, hence Azure Disk. And by placing that content in that Azure Drive, sorry, not disk, but a drive, by placing that content in Azure Drive, you get high availability. Azure blobs by definition store 3 copies of your data, etc. So if something happens to one of the instances, your content is still intact. So that's how Azure websites will come into being when the first request comes in. Okay, and the next time the request comes in, and let's move on to the next slide here. So this is how the request is handled the first time a request comes in. If I move down to the next slide here, and let's look at once your site is in existence, how does the request flow through? In this instance, there is no need to go to the runtime database because all of the quota information, all of the configuration information is already there. So application request routing module is simply going to straight away forward that message to the appropriate web worker role, which will then look up the content and return the content back to the client. Now, there's one other interesting thing to note here is that application request routing is providing. The application request routing modules are load balanced. So any of the instance of the AIR could be called by the load balancer. But because of the header information, on the packets themselves, the ARR module will route the request back to where it was previously served. So you don't have to worry about if you have multiple instances, and we will see how you can scale an Azure website. If you have multiple instances, you don't have to worry about duplicating or synchronizing your session state. You're guaranteed that the request would go back to the server it was originally sent, and that's a property of ARR. Now that we have looked at the key concept of how Azure websites are implemented, let's take a look at the key mechanisms that enable Azure websites. So the first one that we want to look at is the SQL-based configuration, and I showed this to you in the previous slide. Rather than storing all of the configuration data into some kind of a configuration file on disk, all of that configuration data is stored into a database, and that makes complete sense because you don't want anyone touching that file. And as you well know, if you're an ASP.NET developer, if you touch that configuration file, it would cause all of the application pools to be restarted, and that's the last thing you want to do. So moving that configuration data into a SQL database makes sense. The next concept we also looked at through the previous slide is that all the content is stored inside an X drive, which is powered by Azure Blob Storage. And again, that makes your content highly reliable, 3 copies, etc. The next thing is that the content or the Azure website can be dynamically provisioned and provisioned very quickly in a matter of seconds. The Azure websites themselves can be scaled, and the scaling can be based on a schedule. So you can say that I want my Azure website to run 5 instances between the business hours of 9 a.m. and 5 p.m. And then beyond that point, I want the instances to come down to 2 instances or 1 instance. In addition, you can also do a load-based auto-scaling. So you can provide a CPU threshold, and this will become very clear. I'll bring up the screen in a moment. But you can say that you have a CPU threshold, and you can specify what are the number of instances or the range of number of instances, and Azure websites will make sure that as your load fluctuates between that CPU range, it will automatically change the instance count as needed. You can also publish. So not only can you dynamically provision the Azure website, you can publish from any of the source code control systems. You can provision from Git, Dropbox, or TFS. So now that we have seen the Azure website creation and the configuration options, let's look at some of the design considerations and the trade-offs that are available to you as you go about creating Azure websites. So the first one is, we talked about the free, shared, and standard types. So of course the free, as I explained earlier, is a truly multi-tenant hosting with certain quota limits. Standard is also multi-tenant with removed quota limits. And then of course the standard instance is where you get a virtual machine for yourself. So how do you go about deciding which type is right for you? Well, if you're starting out, makes sense to start with the free mode. Then you can move up to the shared mode, and even within the shared mode, you can increase the number of instance count to handle the incoming load. But if you truly want the isolated virtual machine, you probably want the standard mode. And one interesting thing about the standard mode is that since you own that virtual machine, you can designate all the websites that you want hosted inside that virtual machine. In fact, according to the recent Microsoft documentation, you can host up to 500, and yes, that's correct, up to 500 Azure websites in one standard instance. So the next consideration that we want to look at is horizontal versus vertical scaling, and we saw this earlier. You can not only increase the number of counts or instances of Azure websites, you can also decide to host your Azure website in a larger virtual machine. Now, why do you want to do that? Why would you want to scale vertically when you have the horizontal scaling available? Well, vertical scaling would make sense if you have some kind of logic in there where multiple access is not safe which means if you have some kind of a resource contention and if multiple instances are accessing that resource and you don't have safety built into your logic, then you may not want to have multiple instances. Instead, you could go to a higher class machine, more CPU, more memory, and handle your load in that manner. The next design consideration is the request response versus scheduled request. I said at the beginning of this module is think of Azure websites as a place where you can host code that gets activated when there is an incoming trigger, an HTTP based trigger. Of course, that's a very fancy way of describing what a website does. But what if you wanted to execute this code without this external trigger? So you wanted to, on a periodic basis, execute some kind of a code. Well, there are two options. One thing is you can go out to a number of cron job services that are available, and you can define a cron job which says every 15 minutes hit my Azure website, which would cause your code to be then executed. That's certainly a fine pattern. But we will be talking about Azure mobile services later on in this course. And Azure Mobile Services recently added a scheduler capability. So if you're looking for a truly scheduler or scheduled piece of code or logic that has to be executed on a scheduled basis, then you may want to look at the scheduler within the Azure Mobile Services. The next design consideration that we want to talk about is sticky versus stateful sessions. And if you've worked with Windows Azure and if you've worked with web roles previously, you know that the web roles are stateless, which means every incoming request can go to any instance of that web role. And what Azure websites offer you is, because of the ARR or the application request routing module that I talked about in the previous slide, you can have the benefit of the sticky session because ARR module is going to, based on the header information, is going to route the request back to the server which handled the request previously. So if you are considering stateful versus sticky sessions and you're deciding between web roles and Azure websites, this is an important consideration to keep in mind. So with this, we come to the last part of this module, and I want to run a quick demonstration for you. And this is, as I said earlier, this is an end-to-end demo to show you one of the scenarios that we talked about previously. And one interesting scenario is a digital marketing campaign, where every campaign, think of it as a microsite, and that's why I've written microsite provisioning here next to that. Imagine you were called to implement some kind of an automation for a digital marketing company, and they wanted a very simple provisioning engine where every campaign gets its own website. And Azure Websites, based on all of the properties that we have talked about, is an excellent platform for doing that. And we talked about the various reasons, the robustness, the fact that you don't have to worry about hardware and software. You get fault tolerance, you get the scalability, because if you're running a campaign and now suddenly you get a very viral promotion of a certain idea, you get lots of loads, you want to scale to that load quickly, you can do all of that using Azure Websites. So what I'm going to do next here is I have a piece of code written in Visual Studio. I'm going to switch over to Visual Studio here in a moment. And the idea behind that code is, think of that as a tenant provisioning provider. So I have my media campaign defined, and I have now taken that content and then I have stored it in some kind of a repository. In this case, I've stored it in a Git repository. And when I invoke my tenant provisioning provider, it is going to go provision a new Azure website. And not only is it going to do that, it is going to take the template for my marketing campaign and push that template out to that newly provisioned website. And the beauty is that once I have provisioned this website and I have pushed the content to that website, I get an FTP endpoint that I can push additional content or customization to that given website. So with this, we come to the end of this module. And let us quickly summarize the things that we have learned as part of this module. We started this module with motivations for using Windows Azure websites. We described Windows Azure websites as managed execution units, where you don't have to worry about the underlying software or hardware or fault tolerance or scalability. You simply write your code in one of the many languages that are supported, including .NET, PHP, Node.js, etc. And then all the underlying plumbing is taken care of by the Windows Azure websites. We looked at the core concepts, how these Azure websites are dynamically provisioned. We looked at some of the key mechanisms, including ARR. We talked about how the configuration information is stored in a SQL Azure database instance. We looked at the content that is being rendered by Azure websites being stored in something called the Windows Azure Drive, which is Windows Azure Blob Storage under the covers. And then we looked at a demonstration, a specific scenario where Windows Azure websites could come in handy. We looked at a scenario where we had a digital marketing campaign, and we specifically looked at the microsite provisioning framework. And then we also looked at some of the design considerations. We looked at how you can scale Windows Azure websites vertically or horizontally, which means you can have multiple instances, or you could get a higher compute instance, for example. We talked about how you can have sticky sessions by virtue of the ARR module. We talked about the different languages that you could support. So hopefully you walk away with this module having a deeper understanding of what you can do from an Azure website perspective, what the framework has to offer, and the kinds of applications you can build. So welcome to this module 2 of this course. In this module, we are going to talk about compute-intensive apps with Windows Azure Worker Roles. So if you've not had a chance to look at Windows Azure Worker Roles yet, let me give you a very simple definition. So think of Windows Azure Worker Roles as a managed execution environment. So why managed execution environment? Well, you don't have to worry about the software or hardware or load balancing, fault tolerance, etc. So you essentially get a virtual machine on which you can run a long-running or a perpetual task. Okay? At a high level, building compute-intensive apps are simple. So you basically, the idea behind them is you take a large compute-intensive task and you break it down into smaller chunks, and then you have a variable set of worker roles to process these chunks. Okay? The idea is simple, but there are lots of details around this. So why would you want to run a compute-intensive task? What are the common scenarios? Well, let me show you a couple of common scenarios. One would be that you want to run some kind of a simulation. Perhaps you want to run a Monte Carlo simulation for doing option valuation, or you're trying to build a system that requires a lot of computation for doing image processing. With this basic understanding of what is a Windows Azure Worker Role and what are the common scenarios, let's take a quick look at the design behind such applications. Let us look at the diagram that depicts how one or more worker roles can be set up to perform this compute-intensive task. So we start out with the load balancer. This is where our incoming request is going to come from. This request is going to be picked up by a web role or multiple web roles. And this request is going to be broken up into smaller chunks. And for each chunk, we create a message and store that message in the queue. Now, typically, you don't want to store all of the task details that the worker roles has to perform in a queue message, because the queue message may not be that large. So what you typically want to do is store all the details about the task in storage, take the pointer to that, and then take the pointer and make it part of the message that you store in the queue right here. Okay. And then once you have queued the message, you can have one or more worker roles monitoring the queue, picking up the message. Once they pick up a message, they need to go to storage to get all the details about the task. And once you have all the details, they can perform that compute operation, whatever it may be, an image processing task, a simulation task, etc. And once they have completed the computational task, they can store the results back into storage. Okay. So that is the core pattern behind how you would set up multiple worker roles to perform a compute-intensive task. Now, key thing here is, as you can see from this diagram, there are one or more worker roles here. And typically, the key idea behind this pattern is you can have a variable set of worker roles to process this task. And the number of worker roles you typically have is going to depend on how many messages have been queued to the queue, what is the cost implication, etc. And the number of worker roles you have at any given point in time is going to depend on the load in the system, which means how many messages have been queued to the queue, how quickly you want to complete the task, and of course, the cost of setting up these worker roles. And these are the things that we'll be looking at in the subsequent slide. So let's talk about some of the key mechanisms associated with this style of application. The first one is auto-scaling. So I showed you in the previous diagram that you can have one or more worker roles responsible for processing the incoming request. Now you don't want to have too many worker roles sitting idle because that will be additional cost. You also don't want to have too few worker roles because it would mean taking a lot of time to process the incoming request. So what you typically want is some kind of an auto-scaling mechanism where Windows Azure would come in and look at the size of the queue and then based on the size of the queue, bring in additional worker roles, or if the size of the queue goes down, take away some of the worker roles. The next key mechanism we want to talk about is guaranteed processing. So once we have split our incoming request into multiple messages, we want to ensure that a worker role processes a given message in its entirety. So what happens if one worker role picks up a message, goes through the computation task, and halfway through the computation task, there is some sort of an error? We want to ensure that that message is then processed again by another worker role, completed the operation, and then stored the results back into the storage. And we will see how Windows Azure, through the mechanisms such as the visibility timeout, makes this possible. But this is a very important tenet of this pattern. And the third one I want to talk about is related to elastic storage. And typically when you're trying to run simulations, you're trying to perform the same operation over and over again, many times, millions of times. So the results that are generated by such an operation can be really large. And typically you want access to elastic storage to be able to store the results of such simulation. So these are the three key mechanisms that we need to understand. Let's look at how they come into play when designing a system. In the previous slide, we looked at some of the key mechanisms for building compute-intensive applications, including partitioning of work, guaranteeing that the message is at least processed once. But there are a number of design considerations that go along with the key mechanisms that we discussed in the previous slide. Let's take a quick look. The first design consideration is related to partitioning of work. Commonly, this step is referred to as the map step. So you want to make sure that you are utilizing your worker roles that are available to you in an effective manner. And keep in mind that the partition represents a unit of work as far as the worker role is concerned. You don't want to make the unit of work too coarse-grained, because if you did that, you will find that depending on how the messages are queued and dequeued, you'll find that some of the worker roles are working hard and long, while the other worker roles are sitting idle. That is not a great scenario to be in if you are paying for these worker roles by the minute. You also don't want to make your unit of work too fine-grained. And here is an example. Let us say you were trying to run some kind of a simulation that involved invoking a certain computation 1,000,000 times. Now, it might be enticing to think that you can take that each computation, each million of the computation, and make it a unit of work, because then you can have a very fair distribution of work amongst all your available worker roles. But the mechanics alone of queuing 1,000,000 messages and then dequeuing these 1,000,000 messages will be cost prohibitive, and in many cases just this mechanism of queuing and dequeuing may be more expensive than the computation itself. So what you want to do is you want to strike a balance between coarse-grained and fine-grained distribution of work. So oftentimes it is reasonable to start out with a reasonable approximation and then adjust the partition size based on the performance results and costs involved. The next design consideration that we want to talk about is related to aggregation, often referred to as the reduce step. And this step is about summarizing the information at the worker role level. You don't want to get into a situation where you want to take the results of the computation at the each worker role level and stream that information to a central location. To the extent possible, you want to summarize that information at the worker role level and send the summary information back to a central location for further processing. The third design consideration is related to visibility timeout. And we talked about visibility timeout briefly in the previous slide when we were discussing guaranteed message processing. So what is visibility timeout? It is the timeout after which the message will reappear in the queue, unless of course a worker role has completely processed that message and explicitly deleted it from the queue. So why is this important? It is important because if one of the worker roles encounters an error while processing a message, that message will reappear in the queue after that timeout has expired, and it will be picked up by another worker role, and hopefully that worker role is able to complete the processing. This is how we guarantee that every message will be processed at least once. But here again, we have two competing themes. If you make the visibility timeout too long, then you run the risk of not being able to detect an error condition until the timeout expires. If you make the visibility timeout too fine-grained, then you run the risk of message appearing while it is in midst of processing by another worker role. Fortunately, Windows Azure has now added an ability to extend the visibility timeout while a message is being processed. So now you can take the approach of starting small, and depending on how much processing you have completed within the worker role logic, you can now extend the visibility timeout. The next design consideration flows directly from the visibility timeout, and it is related to idempotent processing of message. So what does that mean? It means that a computation can be performed multiple times without changing the result beyond its initial application. So why is it important that you be able to process that same message multiple times without impacting the results? Well, as you saw previously, you could have a condition where a worker role completes half of processing of a message and then runs into some kind of an error condition. The message would appear later and would be picked up by another worker role, which will start processing it all over again. Unless your message exhibits the idempotent characteristic, your overall calculation will be flawed. So it's important that your message be idempotent. The final design consideration also flows from idempotent processing. Just because your message is idempotent does not mean you can have runaway computation. What do I mean by that? Let's say I have a message which is flawed in a certain way that every time a worker role dequeues that message and starts processing it, it encounters an error every single time. If you combine this with the visibility timeout behavior that we looked in the previous slide, which is if a message is not processed, it will appear back up in the queue. So if you put these things together, you can very easily end up in this vicious cycle of message being dequeued, error condition, and then reappearance of the message. So you don't want this cycle to continue because you'll end up paying for lots and lots of compute time. So what you want to do in this instance is treat or look for such messages. And by the way, these messages are called poison messages. And fortunately, Windows Azure Queues gives us the dequeue count, which tells us how many times this message has been dequeued from the queue. and you can set up a certain threshold. You can say that I'm only going to process a message twice. And if I've tried to process this message 2 times, I now deem that message as a poison message. I'm going to write into a log and let someone else come back and look at what is wrong with this message. So as you can see from this slide, there are a number of design considerations that go into designing how your compute-intensive application is going to work. So keep these things in mind. Now let's take a quick look at a completed sample where we will see many of these design considerations manifest itself into different code artifacts. So let us look at the solution structure, and the source code is going to be part of the course. So it's going to be available to you. So I'm only going to highlight the key aspects of this code, and I encourage you to look at this code in detail at your own convenience. Now let's start out by looking at the solution, and I've called the solution option valuation only because I'm pretending that this Monte Carlo simulation is being conducted to do some kind of option valuation. And as you can see here, this solution has a number of projects, and the web worker project, the worker role project, etc. Let us start by looking at the Windows Azure project, which contains the configuration information about the worker roles and the web roles. So let's go ahead and drill down into that. As you can see, here is the web role configuration, and here is the worker role configuration. And if I double click on the web role configuration, you can see that I have an instance count of 1. Similarly, if I click on the worker role configuration, you will see that I have an instance count of 3. Now, one thing I should clarify here before I proceed, I'm going to be using the cloud emulator. As you know, there's a cloud emulator built into Visual Studio. So I'm able to run this entire sample on my machine here, and I encourage you to do the same. You'll be able to not only walk through this code, but also get an F5 experience, debug this code, all without having to deploy this application to Windows Azure. If we had deployed this application in Windows Azure, we could have taken advantage of something called the auto-scaling capability. And I showed this to you in Module 1, where you can go in and say that you want Windows Azure to monitor a certain Azure queue, and based on the size of the queue, you want Windows Azure to provision additional worker roles. I could have certainly done that if we had deployed this application to Windows Azure, but in order to keep this demonstration simple and expedite this demonstration, what I've done is I've pre-provisioned, as you can see in the screen here. Let me show this to you. So as you can see here, the instance count is 3. So I've decided to pre-provision 3 worker roles here. And then to show you the variable in number of instances of worker roles, what I'm going to do is I'm going to have a configuration setting in my application, and my application will then rely on that configuration setting to determine how many worker roles are active at given point in time. Okay, so hopefully this is clear. We are running this code in Cloud Emulator just very quickly, and we are pre-provisioning a set of worker role instances, and then we are using a configuration setting to control how many of the 3 worker roles come into play in our application. So now that we know about the Windows Azure configuration project, let's start out with the web role project. And this is an MVC application, so I'm not going to go into this in detail. You understand the concepts already. And I'm only going to call upon this home controller, and I'm going to go to an action called the submit action. And this is where we are interested in. We have a bunch of validations, not that interesting, but somewhere here you will find that I have a submit job method. So I have a UI, and I will run this application in a moment. I have a UI where I collect certain parameters, and we talked about that in the previous slide. The Box-Mueller method expects a certain parameters, whether it is the mean, the standard deviation, etc. We collect the 5 values, we collect the iteration count, and then we take that information and submit a job in the queue. And in addition to submitting a job in the queue, we also store all of the calculation information, the control information into an Azure table as well. So let's go ahead and look at what submit method is doing. And what we find here is we are going to figure out how many roles are active. And this is where our configuration setting is going to come into play. And I'll show that to you in a second. So we talked a lot about the partitioning strategy earlier on in this session. And we talked about how the partition size represents the unit of work. Making it too coarse-grained or too fine-grained is problematic. And I recommended that we start out with a reasonable estimate and then adjust it as we go. So in this case, what I decided to do was I take the body of work and then I divide it equally amongst the number of worker roles that are active. So if I ran this application with 3 active roles, then I would divide the workload into 3 parts or 2 parts or a single part. Okay. Once I've done this, I'm going to create a bunch of Azure table entries. That's what all the min value, max value, standard deviation go in. And then finally here, I'm going to create multiple tasks for my worker role. So let's go ahead and take a look at that. And if you look at this method here, I'm figuring out how many roles are there. And those are the number of messages I'm going to queue. And here is the add message. Let's go explore that. And you will see here that I'm using the task queue and I'm using the storage library, using the add message here. And let's go ahead and explore that further. And you will see that I have a bunch of overloads of this method available as well. If I wanted to, remember we talked about the visibility timeout. I can certainly specify a visibility timeout, or I can choose to use the default value. Okay, so we've seen how the web role project is going to take the input, split it up into multiple messages, and put that message in the queue. The next thing we want to look at is the worker role project. And here's where the project is. And we are going to go straight into the worker role.cs method. And this is the method where we will continue to loop and look for new messages. So here is the run method of the worker role. This will be invoked. And here I'm going to, see the while true loop here. I'm going to continue to, let me get myself a little bit more space. I'm going to continue to look for my messages in the queue. And this is the interesting part of the code right here. I talked a lot about the poison message handling. And here you can see this in action. I'm trying to determine how many times this message has been queued. If this message has been queued less than 2 times, I'm ready to process it one more time. If it is more than 2, I'm not going to process it. I'm going to write a message to the log and move on. So once I have found a message, I'm going to next start processing it. I'm going to go to the Azure table to get the control information about the task. And there's one other interesting piece of code that is happening here. So I told you earlier that we partitioned the work and divided that by the number of worker roles that were active. It turns out that each worker role is a multi-core machine. So it makes sense to further split the workload into the number of cores that are available. So I figure out my processor count. Once I know my processor count, I'm going to simply use, let's go in here. This is my calculation here happening. Let's go find this method. And in this method, we are going to be doing this calculation. And here you can see the task parallel library. I'm using a bunch of threads, and the threads equal the number of cores I have available in the virtual machine. And once I'm inside there, I'm just using the task parallel library to spawn this computation. And when this computation is complete, we should see somewhere here the aggregation step right here. So as you can see here, here's the aggregation step. Remember, in the design trade-offs, we talked about how the aggregation step is important. You don't want to stream all of this information back to a central location. What you want to do is at the worker role level, to the extent possible, you want to do the aggregation and send the aggregated results up to the main central location. So that's what's happening. And once all of the tasks have been computed, the data is then stored back in the Azure table. And now our web role can go in and display that data using some form of a chart library. So what we're going to do next is going to take a look at the application in action. So let's go ahead and run this application. And again, I'm running this application in the cloud emulator. So it should come up in my local browser instance. And while my emulator is coming up, let me also bring up the Cloud Storage Studio. This is the tool that I used to work with my Azure tables. And remember, I talked about the configuration setting in order to expedite this demonstration, rather than having to dynamically spin up worker roles up and down, which can take a few minutes. What I did was I have a configuration setting which determines how many roles will actively come into play in my application. And as you remember, we already have 3 worker role instances provisioned. So if you look at this value here, right now, I am going to be only using a single instance of my worker role out of the 3. So this parameter's value is set to 1. Let's go back to the browser instance, and it is asking me to log on, and this application is protected by Windows Azure AD. So I'm going to go log in into this application here, and once the login is completed, I'm going to specify my computation. So let's go ahead and create a new job, and let's just call it Applied Azure, and let's call it Applied Azure 1, and let's just say we want to run 5 million iterations. Array size is 1000, the mean is 1, standard deviation is 1, and I'm just making up some numbers here. The minimum value is -1 and the max value is 1. Let's go ahead and submit this job, and I don't want any debug operations, but this is the beauty of being able to run in the cloud emulator. I'm able to debug through this code. So I'm going to remove the breakpoint and allow my application to run here. So it looks like my job was successfully submitted. And what I'm going to do next is go into the monitor tab here and see how my job is doing. And let's go click on the monitor tab, and here you see Applied Azure task has been queued. We are running 5 million iterations, and very interesting to note here that only 1 worker role is being used. We have 3, but only 1 is being used. And if we scroll all the way to the right, looks like our task did indeed complete, and it took about 33 seconds to complete. Okay, and I can very easily run this demonstration again and bump up the number of worker role instances. So I'm going to do that. But before we do that, let's just take a quick look at the data that was computed as part of this task. So I'm going to go ahead and click this, and here are some Monte Carlo distribution curves that have been drawn. And again, these curves here and these graphs are much more detailed as the number of iterations go up, and hence the need for large computation. Okay, so I'm going to do one more iteration of this demo, except I'm going to bring into play more than 1 worker role instances. So before I run this code again, let me very quickly show you. Now I have changed this value to 3, as you can see here. So we are going to take advantage of all the 3 worker role instances. So let's go ahead and run this application again. And it is going to bring up the browser one more time, and we will try to run a similar calculation. And note here that the times that are required to calculate this is not going to be accurate. We are indeed running in the emulator. So let's go ahead and log into our application one more time. And we are going to submit another task here. So let's go ahead and create a new task here. Let's call it Applied Azure 2 this time. And I'm going to select 5 million iterations again. I'm going to pretty much select the same values. The minimum value is -1 and the maximum value is 1. Let's go ahead and submit this. And here is my job ID that was assigned to me. Let's go into the monitor tab, and we see Applied Azure 2 here. And what is interesting now, note that 3 worker roles are in play instead of the 1 the previous time. So what would have happened here is we would have taken the workload, split it into 3 parts. So as a result, we spawned 3 messages to the queue, and each worker role will then pick up one single message and start processing that computation. And let's go ahead and see if this job got submitted. Not yet. And we can wait for a few seconds here. Looks like that job did indeed complete. And I'm going to go ahead and go look at the charts again. And you should see charts are similar here. And this time you see additional data because we waited for the entire computation to be completed and all of the data uploaded into the Windows Azure storage. So with this, we come to the end of the second module. As you can see here, we took a compute intensive application. We built it using the architecture that we showed earlier in this module, a web role which collected the data, and then we partitioned the work. We created a bunch of messages, and then we had a bunch of worker role instances waiting for these messages to come in. As they picked up these messages, and then using the visibility timeout, we made sure that these messages were processed completely. In addition, we did the poison message handling. We do not process any message that has already been dequeued more than twice. And then once we have collected the data, we aggregate it at the worker role instance, and then we store the data into an Azure table. The web role can come in, the MVC application hosted in web role, I should say, can come in and draw this application using a charting library. Thank you, and see you in the next module. So with this slide, we come to the end of this module. Let us summarize the things that we have learned in this module. We started out with the motivations for using Azure worker role, and we described it as a managed execution environment for long-running tasks. We talked about the core concepts, and mainly we focused on this classic async web worker architecture, where you have these requests coming in, which one or more web roles queue to a Azure storage queue, and then we have one or more worker roles that are looking for these messages in the queue, pick messages out of the queue, and then do some work. And then we looked at some of the key mechanisms. We talked about auto scaling, how you can get additional worker roles based on scale. We talked about elastic storage. And then we talked about guaranteed process once queuing for our messages. And then we looked at a detailed demonstration of how you could use worker roles to implement something like the Monte Carlo simulation. And in this case, we looked at the Box-Mueller transform. And you will recall that we ran the simulation twice. We ran it once with a single worker role, and then we ran it again with the number of worker roles to 2. And then we saw that the work was split and being performed in parallel across the 2 worker roles. And then we concluded this session with some design considerations about how do you determine what is the optimal partition size when you are splitting this work amongst worker roles. We looked at the concept of visibility timeout. Every time a message is queued, and every time it is retrieved by one of the worker roles, the message becomes invisible. What should be the right size for that visibility timeout? We talked about how poison messages can be a problem and how Windows Azure Queues allows you a way to handle poison messages. So this is the summary of this session, and I would like to point you to module 9, which is about big data. And once you look at this module and the big data module, you'll realize that in this module, we were responsible for setting up a lot of plumbing ourselves. So we had to provision these worker roles. We had to worry about what happens if one of the worker role dies. How does the visibility time kick in? We had to worry about partitioning size and all of that, and message passing. And we will look at how a Hadoop architecture provides us all of those capabilities so we don't have to worry about the underlying plumbing. So I encourage you to watch this session so that you get the concepts of storage and queues, but then also After you watch this session, go on to Module 9, where we talk specifically about big data and how we are using HD Insight to do large-scale data processing.